All right, so for day 4 of our probability unit, we're going to talk about permutations. Um, so when we discuss permutations, we're going to find the number of permutations of a set of objects and find probabilities. So a permutation is an arrangement or listing of objects in which order is important. So these are like our dependent. If you want to write that word, we can write dependent events. So this would be like if I had, it's kind of like our study Allen questions that say that we're going to make a password using the numbers 0 through 9. And we're going to have the 3 number password. Okay, and the first number we would have, 0 through 9, which is 10 different numbers. But we can't repeat them. So now we can do 0 through 9, but this number cannot be that number. So we would go to 9. And then we would use 0 through 9, but this number can't be either of those 2 numbers. So then we'd only have 8 choices. So the first number we'd have 10 choices, then 9 choices, then 8 choices. So we represent that using 10 times 9 times 8. And the probability of choosing that combination would be 1 out of 10, 1 out of 9, and then 1 out of 8. We multiply those together to get your probability. Okay, so this is where we say order is important. So for example here, a bowling team of bowlers has 5 members who bowl one at a time. In how many orders can they bowl? So here's some questions to kind of work us through this. It says, how many choices are there for the first bowler? Well, the first bowler, we have 5 different choices. And since that bowler is not able to bowl again, how many choices are there for the second bowler? Well, I have 4, and the third I have 3, and then I have 2, and then I have 1 choice. So if I move this out of the way, let's say multiply those numbers together to find the number of permutations. So 5 times 4 times 3 times 2 times 1 is 120 different orders. Okay, so the question is, in how many orders can they bowl? They can do it 120 different ways, because you could do 5 different ways for the first person, and then 4, and then 3, 2, and 1. So in all, it'd be 120 ways. The reason we calculate permutations is because if I asked you what is the probability that we selected a certain way, well, that would be 1 out of 120. Okay, so it'd be really difficult to choose that. All right, so a raffle. A school fair holds a raffle with first, second, and third prizes. 7 people enter the raffle, including Marcos, Lily, and Heather. What is the probability that Marcos will win the first prize, Lily will win the second prize, and Heather will win the third prize? Okay, so how many people could win the first prize? Well, there are 7 people that could win the first prize. There are 6 people that could win the second prize, and there are 5 people that could win the third. So I like having lines like this, and I would put 7 times 6 times 5. Okay, because we have first place, second place, third place. Okay, and so we're going to multiply those numbers together to find the probability. So 7 times 6 times 5 equals 210. So there's 210 possibilities for this. And we're asking, what is the probability of something very specific happening? We want Marcos to get first, Lily to get second, and Heather to get third. So that would just be 1 out of 210. Okay, so now we're actually calculating the probability. This is something very specific happening with Marcos. He can't be second or third. We want him to be first. So that's just one situation that happens where he's first, Lily's second, and Heather is third. So again, order is important in these situations. A garage door code has 5 digits. If no digit is repeated, how many codes are possible? So, all right, I'm going to draw my lines. 1, 2, 3, 4, 5. Okay, there's my 5 digits. Now, if I think about it, I have 0 through 9, all right, for my possibilities. So that's 10 numbers, okay, because 1 through 9 is 9, plus then I have 0, so that's 10. Now, it says if no digit can be repeated. So if I could repeat it, I could have like a code like 11111. Okay, but this says I can't repeat it. So I have 10 choices for the first number, and then I only have 9, and then 8, and then 7, and then 6. Okay, now we can use our calculators to figure that out. 10 times 9 times 8 times 7 times 6. And that equals a pretty big number, 30,240. Okay, so there are this many codes possible for a 5-digit garage door code. Okay, so what are your chances that you guess someone's code correctly on the first try? Well, that'd be 1 out of 30,240. Okay, so that'd be pretty difficult for you to guess someone's code just at random, unless you knew what numbers that they used. Adriano, Julian, and 3 of their friends, so that's 5 people. So 1, 2, and then 3 friends, so that's 5 people. Just going to keep track of that. We'll sit in a row of 5 seats at a baseball game. If each friend is equally likely to sit in any seat, what is the probability that Adriano will sit in the first seat and Julian will sit in the second seat? Okay, so we pretty much just have 2 seats that we're talking about here. We want the first seat and the second seat. Okay, whenever we talk about places like first place, second place, third place, and things like that, whenever we talk about places, order is important then. Okay, so now we have 5 friends. So how many people could sit in the first seat? 5 different people. How many people could sit in the second seat? 4 different people. So 5 times 4 is 20. And what is the probability that Adriano sits in the first seat and Julian sits in the second? Well, that'd be 1 out of 20. Okay, that's a very, very small chance of getting that very specific thing to happen. So that'd be 1 out of 20 that all the Adriano sits in the first seat and Julian sits in the second. Our last example for today: a family discovered they can stand in a row for their portrait in 720 different ways. So how many members are in the family? So basically we need to do a permutation, and it has to equal 720. Okay, so permutations usually go all the way down to 1. So I'm going to start right here with 1. Okay, 1 times 2. Okay, that would mean we had 2 people in the family. Well, we know that 2 times 1 does not equal 720. So now I need to do times 3. Okay, and if I do 3 times 2 times 1, that equals 6. So I'm not there yet. So I'm going to do times 4. So I'm going to do 4 times 3 times 2 times 1. And that equals 24. So now I'm going to do times 5. Right, and that equals 120. So now I'm going to try times 6. All right, and now that equals 720. So how many members are in the family? There are 6 family members. Okay, and this would be by far the easiest way to do this. You have to get 720 ways, and we know that we're going to be kind of counting down here: 6 times 5 times 4 times 3 times 2 times 1. Now another way to write this, it's kind of interesting. We can actually, there is a factorial symbol, and this can be written like with an exclamation point. So 6 factorial, that's how you read it. 6 factorial equals 720. Okay, and what 6 factorial tells us to do is it tells us to go 6 times 5 times 4 times 3 times 2 times 1. Okay, so 6 factorial actually means 6 times 5 times 4 times 3 times 2 times 1, which equals 720. Okay, so just kind of a little background information there of what that exclamation point does for us in math. Okay, and that's our last example for the day 4 lesson.